Welcome to math class. We're going to work on lesson 96 today. So, the problem solving was very tricky today. This is probably the hardest problem solving problem that I can think of that we do the entire year because it's just awkward. It's a real awkward problem. So, the best way that I know to find the solution to this is we're going to use a tree diagram. And so a tree diagram, which is, I think they suggest that for you to use that. Yeah, use the tree diagram. Okay. So I also like to draw a picture because this is really hard. It was hard for me to figure out what it was that they wanted me to do on top of solving it. It's like, well, I didn't even understand what the problem was. I had to read it 2 or 3 times. So if you were like that too, I think it's a very awkward problem. So here we go. We're going to draw a picture. Here's a picture of a classroom. Okay. All right. So what they're saying is, choose an appropriate problem-solving strategy to solve this problem. There are 3 light switches that each control a row of lights in the classroom, okay? So let's say here's a light switch. This is light switch 1. Here is light switch 2, and here is light switch 3. So just imagine like our classroom, and here's like the wall that has the homework board on it. Let's pretend there's a switch there, and a switch there. And then one controls these lights, 2 controls these lights, and 3 controls these lights. So like in our classroom, we had just the one light switch and it controls all of them. So that's why it was kind of hard for me to wrap my brain around this problem. So this one light switch, it only controls these. All right? Okay. So, what's the rest? A row in front, a row in the middle, a row in the back. Okay. Make a tree diagram to find the different ways the rows of lights can be turned on and off. And then you're going to use the tree diagram to help you figure out how many different combinations are there. All right? This is a strange problem, but yeah, bear with me. So, let's start. So we're going to start with the front row. Okay? So this will be the front. And this will be the back. All right? So, if we have a light switch, what are the 2 possibilities that we can have to begin our tree diagram? The lights can either be on or off, right? Okay, so I'm going to put those 2 possibilities. I'm going to erase what the lights look like and replace it with our tree diagram, okay? So here's our 2 possibilities. They can either be on, I think, how about if I do it this way? I think you'll be able to see better. I had an idea. They either can be on, or, oh, I've got an even better idea. You guys probably can't read that. That's why I like whiteboards, because hopefully when you're problem solving, you might have an idea and think, oh, this is great. If it doesn't work, just erase it and start over. You can do that with your homework too. If you have a problem solving strategy and you think, oh, this is going to, and then you work halfway through it, you think, I'm lost, this isn't, erase it, start all over. That's part of the problem solving process, okay? So, the front light, we said there's 2 possibilities, on and off. So, off and on. Isn't that cute? All right. So, put a little artwork in our map. All right, so on and off. Now, let's go to the second row of switches, they can either be on or off, right? Okay, but depending on this first row, if the first row is on, I have two possibilities for my second row, right? So we're gonna have to do, remember our tree diagram, we're gonna do this. I will also have to do it if the front row is off. Then there are two possibilities for the second row. So let's do that. Okay? Does that make sense so far? The first row will either be on or off. The second row will either be on or off, but we had to provide for both options for what the first row was, right? Because these are all individual switches. They can be either on or off, independent of each other, okay? All right, so now we get to the back row. If the front row is on, the second row is on, then the third row has two possibilities for each of those, right? Oops, I have used the wrong marker color. What is wrong with me? Let's get that fixed, Mrs. Pullman. Come on. All right. Then there's two possibilities here. And it continues down our board of all the different possibilities. So, let me just get my colors all done here. All right, so let's look at all of our possibilities because our tree diagram is now complete. So, find my cap. I don't want them to dry out. All right. So we could have the front row on, the second row on, the third row on. We could have the front row on, the second row on, the third row off. We could have the front row on, the second row off, the third row on. We could have the first row on, and so and so. You can go right down this diagram. So how many combinations do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 8 combos. All right? There you go. You can rewind this and do it along with me. I would suggest that you do that because it kind of helps you visualize the problem. And that's important in a lot of things in life. You first have to know what the problem is. And that with this problem, it was written so awkwardly. A lot of times it's hard to even figure out what the problem is. So draw a picture, revisit it, see if you can visualize the problem, and then try to work it, okay? All right, we are going to go into today's lesson, lesson 96, on averages. And I love this problem, and I wish I was with you. I do this problem with M&Ms. Doesn't that sound like fun? I know, but bear with me. I might have to bring you all M&Ms next year. Yeah, make up to it. I'll make it up to you, okay? All right. It's on averaging, and averaging tells us how we use it, and you guys use it every day, and you may not even realize that you use it, but when we have a group of data, like M&Ms, and what I do, I go around the classroom and I give every student M&Ms, but I don't give everybody the same. I might give Elliot 7, and I might give Umbria 11, and I might give Sarah 14, and I might give Avika 2, and I might give Sophia F 38, and I might give Ariana 90, and I might give Hudson 1. I mean, it's just, you just give everybody uneven. But then at the end I say, okay, now everybody tell me how many you have, and I write down all those numbers on the board, And then I say, well, the average number of M&Ms given to each student is. Now you might say, why is that important? Why does it matter what the average is? Well, it's very important probably to the person who got one, because what the average means is if I have 24 students and I have this many M&Ms, I need to make sure that everybody has this amount. So everybody has the same, right? That's one way to use averaging. Another way to use averaging is, a lot of you want to know, Mrs. Pullman, what did I get on my test? What did I get on my test? What did I get on my test? Because what I do at the end of the year is I take those test grades. Let's say you get a 90, and then you get a 100, and then you have a bad day, and you get a 62. And then let's say one day you get a 88. All right? How do you get your math grade at the end of the year? Well, what I do is take an average of your grades. So what I do is I add up all your grades, and then I divide by however many you had. So like if this were the case, 2 plus 8 is 10, 9 and 1 is 10, 16, 16 and 8 is 24. So you have a total of 340 points. Now, what I then do is I take that 340 and I divide by however many tests you took. You took 1, 2, 3, 4 right here. So if I divide 340 by 4, 3 can't divide by 4, but 34 can divide by 4. I can divide that 8 ways. 8 times 4 is 32. Bring down my 0. 20 divided by 4 is 5. So the grade you would get for math is 85. That's your average grade that you made on your tests. Does that mean you got an 85 for every test? No, because you got a 90 and you got a 100 and you had a bad day and had a 62. And so I average those out. That's how you get your grades. That's how your grades are figured for every class you take. Okay? So there are a lot of uses to know how to average numbers. And that's what our class is on today. Look at your math book on page 607 at the very bottom. It shows that an average is a way to describe a set of data using one number. So there you have a stack of coins. You have 8 in one stack, 3 in another stack, 4 in another. Okay. Page 608. At the top, there are 15 coins in all. If we arrange the coins to have an equal number in each stack, we get 5 coins in each. Okay? Again, very important if that would happen to be cookies, M&Ms, I don't know, Pokemon cards. I know it's Pokemon cards. Okay, fine. You know, whatever that you guys might have an interest in. If I'm dividing it out among you all, it's very important that it be equal, right? Or an average number. Take a look at, okay, we say that the average number of coins in each stack is 5. Finding an average is a 2-step process. Hello, the last 2 days we've been doing 2-step process problems. Sometimes they're word problems, sometimes they're not. Remember the number line problem? Remember the find x when you have x, you need to find y? Our linear equation that we did, okay? First, we find out how many there are altogether. How many do we have total? How many points did we have altogether for your math test, right? Then you divide it by how many items you have so that you can divide those points out equally among however many you have, okay? M&Ms. If I gave you all M&Ms and I distributed them out like my example, I would the first step to getting them equal would be, how many total M&Ms do I have? Okay, then how many students are there? I'm going to divide that total by however many students I have, and that will tell me how many M&Ms I need to give each student. Okay, so at the end of the class, you would have all had the same amount. Okay, yeah, it's kind of traumatic when you're the one that I give one M&M to, and you think, wait a minute, this isn't fair. Yeah, so I do fix it by the end of the class. All right, let's take a look at the example on page 608. 4 vans carried the team to the soccer field. There were 5 players in the first van. 4 players in the second van. 3 players in the third. And 8 players in the fourth. Okay? Then what was the average number of players per van? Let's count them up. 5 and 4 is 9. 9 and 3 is 12. 12 and 8 is 20. Okay, so we've got 20 players. Now, since there were 4 vans, what's the average number in each van? 5. There'd be 5. The average is 5 players per van. Now, were there 5 in each van? No, but we're just saying if we distribute them equally, there would have been 5 in each van. Okay? All right. Now, I think you're good to go on your lesson. I do want to tell you this one thing before I turn you loose. Sometimes when you average things, every problem that we did, it's turned out even, right? Of course, that's not always going to happen. Have you ever heard the term, what is the average number of children that a family has in the United States? What's the average? And I know a lot of you might have heard this term. There are 2.2 children per household, per family. That's the average for the United States. 2.2 children. Well, first of all, I hate the word point, right? It's very unmathematical. You'll hear it a lot, like in the news, people in general talking. I say it sometimes just because it's easier to think, to say. People visualize it better than 2 and 2/10, right? Because there are a lot of people who aren't as mathematical as we are, right? So 2.2 children. Does that mean that there are 2 kids and then you have 2/10 of a kid walking around somewhere? Yeah, no, that's not what it means. It means they've taken all of the families in the United States, divided up how many kids each family has by how many total families there are, and it works out to 2.2. It's not an even number, okay? It's an average, all right? And sometimes it doesn't work out equally, all right? Okay. How do you know how many kids are in each family? Well, that's a topic for social studies. We're going to talk about the census. Did you know the census is a direct, how do I want to put it? It comes directly from ancient Rome. Did you notice in our ancient Rome book that we've been reading, Detectives in Togas, they went to see the censor? And we take a census? Yeah, we'll get into that in social studies. All right. See you next time.